Looking at lesson 32, this is going to focus on graphing systems of equations. So we'll do some of the exercises, a couple of the examples, and see how it plays out. This is also going to use Desmos.com, so you're going to want to be able to look at that. So what we could do ahead of time is we go ahead and put y equals 2x in there, and that creates this graph as such, so that way we can see a line. So in this opening exercise, they ask us or tell us that if we are given a line of y equals 2x, is there a point on the line at a distance of 3 from 1, 3? They ask us to draw a graph that shows where this point is at. So one thing we can do in Desmos is we could put this dot 1, 3 on the graph, and they want to know, is there a place that is a distance of 3 from this point that would intersect on the line as well? And so this brings in basically the equation of a circle. So the equation of a circle is x minus h squared plus y minus k squared equals the radius squared. This is what's going to come in, is our hk is equal to 1, 3, and our radius is equal to 3. So when we write this and fill this in, what we're going to basically do is plug in h and k. So you'll have x minus 1 squared plus y minus 3 squared, and our radius is 3, so 3 squared is 9. And so remember, the question is, given the line of y equals 2x, is there a point on the line at a distance of 3 that is away from the point 1, 3? Explain how we know. And so if we go to Desmos and we put in this particular piece, the x minus 1, and we square it, and then we put plus y minus 3, and we square it, and we set that equal to 9, is what we see is we now have a circle with a radius of 3, and there is a point here and a point here that falls on that red line that is a distance of 3 from the center of that blue line dot, which is right here. This is our center, 1, 3. And as we know, everywhere in a circle, the distance of 3 can be pointed out in any direction on the circle. So that's what the opening exercise is about when we take a look at that. In exercise number 1, they're going to ask us to take a look and solve this system right here. X minus 1 squared plus y minus 2 squared equals 2 squared, which is really just 4. And the equation of y equals x plus 2. So what we'll do is we'll make a little bit of room here. Move this down, we'll move this here, and we're pretty much going to take and substitute this 2x plus 2 in for y, and we're going to end up solving this. So if we wrote it out, if y is equal to 2x plus 2, we're going to write x minus 1 squared plus, and instead of putting y, we're going to put 2x plus 2, square it, and that's equal to 4. Well, hold on. We got the 2x plus 2. Make sure you put your minus 2 in there. You square it. That's going to equal 4. Now, the neat thing about this one, and it's kind of set up this way, is 2 minus 2 goes away. So now you've got x minus 1 squared plus this goes away, so you end up with 2x squared equals 4. So if we multiply this out, you get x minus 1, so that gives you x squared minus 2x plus 1. this part right here becomes 4x squared, and that's equal to 4. So we'll combine like terms. X squared plus 4x squared is 5x squared. You got your minus 2x, and then if we were to minus 4 over to this side, you get minus 3, and that would equal 0. So if that's our piece, we can factor this out, and so you get x minus 1, and then you get 5x plus 3, and so our resulting pieces is x equals 1 and x equals negative 3/5. Now, how do I find the corresponding y values that go with this? Is we would plug each one of these into here. And so we would say y is equal to 2 times 1 plus 2. So that's 2 plus 2. Y is equal to 4. So that means one of our intersection points is at 1, 4. And if we were to do this one, y equals 2 and then negative 3/5, and then plus 2, and when we solve that, you're going to get y equals 4/5. And so then our other intersection point is negative 3/5, 4/5. They asked what are the coordinates for the center of the circle. The coordinates for the center of the circle is h and k. So if that's the case, this would be our h, and this would be our k. So the coordinates for the circle, center of the circle, is 1, 2. And they asked, what can you say about the distance from the intersection point to the center of the circle? Well, that would be the radius of 2, so it would be a distance of 2. Remember, if this is a 4, 2 squared, this is our radius right here. And then they say using our graphing tool to graph the line and the circle. So we'll do that just to kind of take a look at what that is. So we'll clear this off from our last example. And so one of our problems was x minus 1 squared plus y minus 2 squared equals 4. So this is our circle. And if we were to put in our other equation, we would say 2x plus 2. This is our other line. The center of our circle, we said, was at 1, 2. Never hurts to go ahead and graph the center of the circle to make sure it's exactly where you think it was going to be at. And so what are we looking at is we're looking for the intersections. And so we get 1, 4, which we did by algebra. And this is our negative 0.6, which is negative 3/5, and then 0.8, which is our 4/5. And so we're able to take a look at that and see how that looks. Of course, I would, it's not a bad idea to sketch this graph in your book if you want to. So with that being said, we're going to take a look at example number 1, where they want us to rewrite this by completing the square. So we won't actually solve with completing the square. We're going to rewrite this. Or in other words, our goal here is to be able to write the equation of a circle. And so we want to be able to write the x minus h squared plus y minus k squared equals r squared. So to do that, what we're going to actually do is we're going to rearrange this a little bit so that it says x squared. We're going to put the minus 4x right next to the x, and we're going to put a blank right here. This is what we're going to use to create our perfect square. Then we're going to write another one where it says plus, in parentheses, this is where we're going to build the y models. So y squared plus 2y plus blank. And so that's going to be equal to negative 1. Now remember, if I'm putting these blanks on the left, equations always state that what I do on the left, I have to do on the right. So I'm going to put a plus blank and a plus blank. And so remember, if it helps you, If you don't know what goes here, you could do b divided by 2 squared, and that'll help you know what goes in each blank. So if we were to take 4 and divide it by 2, that would be 2. If we square the 2, we get a 4. And so we'll put a 4 in that location, which means we have to put a 4 over here. 2 divided by 2 is 1, and we just square that, we get another 1. So we put a 1 there, and we put a 1 there. That makes these both perfect square trinomials, hence the idea of completing the square. And so if we were to factor this, we would end up with x minus 2 squared. If we factor this one, we would end up with y plus 1 squared. And on the left-hand side, or the right-hand side, negative 1 plus 1 is 0, and so that leaves us with a 4. This becomes our equation of the circle. So what do we note from this? That means we can identify the center. The center of our circle is going to be at 2, negative 1. Remember, the equation itself is established with minus signs. So you have to actually think opposite of what you would traditionally think. So instead of writing a negative 2, we'd write a 2. Instead of writing a positive 1, we'd write a negative 1. And so since this is r squared, then that's going to make our radius 2, because the square root of 4 is 2. And so this gives us the info that we need. What we're going to do is we're just going to confirm that we get the circle that we want. We should have a center at 2, negative 1. We should have a radius of 2. And we're going to graph it in this version right here. And so if we did that, and we take all that out, so our result we said was x minus 2 squared plus y plus 1 squared, and that was equal to 4. So there's our circle. We claimed our center was at 2, negative 1. So there it is. That's correct. That's our circle. Now, a neat way, if you want to check while you're doing your work and you want to make sure it's actually correct, if you did it right, you could actually type in the original form. So x squared plus y squared minus 4x plus 2y equals negative 1. And if it's correct, you're going to end up with a circle directly on top of the circle that we just drew. So like I can turn this off and see there's the blue circle, turn it back on. It's directly on point. And so that lets you also be able to validate and check that the answer you wrote right here in circle form is correct to this version right there. In exercise, well, this continues to be example number 1. And they contrast what happens if we had this. And so rather than, well, we could show the example. You know, we can reorganize this. Again, our goal is to write this by a circle standard. And so we would write x squared. We bring the minus 2x right here. We put a blank because we're going to complete the square. And then we'll do the same thing with the y values. And so that's going to be equal to negative 19 plus a blank plus a blank. And so here, 2 divided by 2 is 1. We square that, we get a 1, so we put a 1 here and a 1 here. 8 divided by 2 is 4. We square that, we get a 16. So we'll put a 16 here and a 16 here. So this side is going to end up being x minus 1 squared. This one is going to be y minus 4 squared, and then negative 19 plus 1 plus 16 is going to equal negative 2. Now, this is the point of this problem. This right here is a negative number. That means the radius does not actually exist. The radius has to be a positive distance on the circle. So if we were to graph this, there would be no graph. There would be no radius, so therefore there would be no circle. So anytime that the number on the right ends up being negative, then you're not going to have a circle. Ends up being a null set or something that does not work in these cases. So exercise 2 is just kind of an option to play with. What happens if circles do this and that and everything else? So if we started with two circles, let's say one that has a radius of 5 and one that has a radius of 3. That means we would start with some equations that would look like this. X squared plus y squared equals 25, and then x squared plus y squared equals 9. So what we'll do is we'll take a minute, we'll actually graph these. Now, to set it up, I'm going to actually type it in as such, x minus 0 squared, and I'm going to put y minus 0, and we'll square that, and we'll set that equal to 25. That's that circle there. And so then we'll do the same thing, x minus 0, and you'll see why I'm putting the zeros in a minute. And then we'll do y minus 0, and then we'll square that, and that's going to equal 9. And so now what they're asking you for in part A of exercise 2 is what happens if the distance between the two circles was equal to 8. The centers of the circles was 8. So right now both centers are at 0. So let's say we move this one, let's say, to the left. And let's say we move this one to the right and then one to the left. And so now, if we take a look at this, one center is here, and then one center is here. They are a distance of 8. And so what you have is you have two circles that are tangent to each other. What if in part B they said they have a distance of 10? So let's say we move one over a little bit further, so we'll change this to a 7. Now the centers are a distance of 10 apart. And in this case, you notice the circles do not touch. In part C, they say, what if the centers are a distance of 1? And so maybe we'll make this a minus 2. And so this is a distance of 1. Again, you can see the centers are inside of each other, or next to each other, a distance of 1, and they do not intersect. That's kind of what they're showing. I'm not going to delve on exercise 2 any further than that. This is something that I would encourage you to play with and take a look maybe at letter D, letter E, F, and G. This is more for manipulation and play than it is anything else. So I'm not going to delve on that any further. By the way, the most important things in this section is example number 1, being able to rewrite this as an equation of a circle. So you want to make sure that is your absolute number 1 takeaway in this particular piece. And if we wanted to take a look at example number 2, this would be the second most important piece, is finding the distance between the centers of the circle. Now, technically you already know how to do this if you know the distance formula. So if we were to move this out the way, we'll slide this over here and make a note that the distance formula is the square root of the difference of the x's squared added to the difference of the y's squared. And so that's what we're looking at in this given piece. So what we need to do is we need to know the centers for each one. Since this says x squared plus y squared equals 5, then the center for the first one is 0, 0. The center for the second one, since this says minus 2 and minus 1, then we know the center for this one is 2, 1. And so if I want to know the distance between the two centers, then I could plug those in, and I could say distance equals the square root, and we could say 2 minus 0 squared plus 1 minus 0 squared. So you get 2 squared plus 1 squared, so you get 4 plus 1 with a radical, so you get the square root of 5. That is the distance from center to center on the circles. So if we wanted to graph that, we could. So we would take these off. And so that would be what? X squared plus y squared equals 5. Whoops. X squared, and then equals 5. And so we know the center for this one is at 0, 0. And if we graph the other one, that would be x minus 2 squared plus y minus 1 squared, and that's equal to 3. And we said the centers for that one was at 2, 1. So that's our two centers. So what is it that we found by finding the square root of 5? We found the distance between these two centers was the goal of example number 2. We're not going to worry about exercise number 3, and we're not going to worry about example number 3. So upon completing this video, your goal is to be able to work on the problem set, and that's going to be numbers 1 through, let's just say 1 through 10. So your goal is to look at problem set numbers 1 through 10. And again, if you have any questions, obviously go back and rewatch the examples in this video. And if you need more guidance than that, then come by and ask, and we'll get you the help that you need.